14 in the notes.
You say 14.
Can I plug in negative numbers for the left here? This left function, can I plug? No, it's an even index, right? So the smallest number, use a 1. I get a 1 as an answer. What about this next one? For me to put a 2 in? What is, and I'm just using this symbol here, the square root of 2? Is that a nice, neat number? What number instead of 2 would make more sense?
3.
Let's try it. If I do a 3, did that get any nicer?
No, let's try 4. No, 5.
4 does work, right?
Wait, 4
The square root of 4? Well, if 1 and 4 work, Kenzie, what would the next number be? 9er. Come on. Yeah, I'll accept it. 9, fine. All right, students, when we're looking at this here, you must, that make sense. Do not just keep, oh yeah, let me just do 7, then 8, then 9. Think about what actually makes sense with these problems here, okay? However, in this one, can I use negative numbers under an odd index? I can, right? So negative 2, right? Could I do something for negative 7? Negative 6? 5? Negative 4?
Negative 2.
Negative 2? Yes.
That is
Negative 1 times itself 3 times is negative 1. What about 0?
0 is 0 itself.
What about 1? We got a stew going. What about 2? 3. Right back to it. What would the next number be? 8. These are a word that I've said once this semester. One day. Let me clarify that. But I used it a lot last semester. Parent functions. Remember your mommy and daddy? Parent functions. Everything stems from this. Let's just focus right here on square roots. In fact, let's move it up a little bit here to see this. I have 3 different transformations. It's okay, Stephen, I got it.
I was going to do that for you, but no. But I know.
What does the 3 do? What direction? Is that a whole direction? Left 3 or right 3? Opposite of the inside? Same on the outside. So right 3. It doesn't matter which order that you list the transformations in. What about the 1? Mitchell, what do you think? Oh, yeah.
And a factor of 2.
Now, what happens with that 2, though, right? We saw a number attached to the front, connected by multiplication. If the number is bigger than 1, we know that it was a stretch. If it was between 0 and 1, vertical stretch by 2. So here we go. Students, if I were to start back at the beginning and just use the same T-chart that I have here, 0, 0, 1, 1, 4, 2, and 9er 3. So all I'm going to do here is I'm going to take the Y value and just multiply it by 2. That's how it stretches it. It's by a factor of 2. Then I can technically do the horizontal and vertical. What I mean by that is I can move each one of them up 1 and right 3. So right 3, up 1. Right 3, up 1. Right 3, up 1. Right 3, up 1. This is the new way that I'm going to graph this function. So maybe it's helpful for you to say, okay, here was the original graph, and what was it, 12 comma, oh, I'm sorry, 9 comma 3. But here is the shifted graph. Doesn't that kind of look like a parabola right there? It's just a sideways parabola. So then it was 4 comma 3. Then it was 7 comma 5. It was 12 comma 7. Be careful. I may or may not need both of them on the graph. Make sure you read the directions. If it's asking for both the parent and the translated function, make sure you have both. If it's just asking for the translated function, make sure that this one that I have in the block here is not there. Okay? We can take a look at a couple others. I could move backwards. If I did move backwards, wouldn't those be easy? Because which direction is this moving to, Allie? Right 2, left 2, up 2, or down 2? Down 2, right? I went backwards 1 page. So, student, that would be, yes, I do. See how each of those points in black are just translated down 2 or left 3. Again, here are those initial points. But if I just move each of them, but just shifted around the graph. That's square roots. Real quickly, we could do the same thing with cube roots. If I fast forward here, so I'm now going back to 15. 2's on this graph. So I'll count by 1's going up. But then 2's going side to side just so I can fit everything here. What direction does this get shifted? Isn't this just up 1? So if I take a look at my parent function of 0, 0, 1, comma 1, and negative 1, comma negative 1, of negative 8, comma negative 2, and 8, comma 2. There is the graph here, but I have to shift it each of. We could do the same thing. This would just be right 2. So I have the entire graph, but notice it could just get right 2. See how it's the entire graph, but it's just been shifted. There we go. Students, one last thing that I want to show you, at least with the graph, is right here. There's still 3 transformations. See if you can find these 3 transformations. I'll give you a hint. One of them is down 2, and the other is left 1. Marin, what does that negative sign do? Over what? Does it reflect it over the y-axis, or does it reflect it over the x-axis?
X-axis.
Any thoughts, Marin? Yeah, you got it. Reflect over the x. So we could take a look at each of those points. The last thing I want to say, are these two problems, are there GCFs right here? Is there a GCF? A number that 9x and 18 share? If I use factoring to remove the GCF, is that GCF a perfect square? Y side x plus 2, it goes left 2, and it stretches by 3. What about a GCF here on letter B? Is there a GCF there? Y equals the cube root of 8 and then x plus 4. So it's really a 2 on the outside with an x plus 4 on the inside.
All right, we have a minute left, Mr. Scanlon.
Less than that. Stretch 2 and left 4. Take a look. Remember, some of you, what should I write down for work? Maybe you could tell me shifts there are. Right? That would be something that you could, if you have a moment, please put up your chair.
All right. I'll be here with 7B and 7C.